Okay, folks, let us carry on with the trigonometry. We got this from Valentin Machejo. Valentin, thank you for this. Your questions are beautiful. I do not want to waste any time because I want to do all the questions you sent us and then go over to the calculus. So let's look at the first question. The instruction here is to simplify, oh, where's my pen? To simplify this expression over here. And folks, look at this mark allocation. It looks like a lot of work, but because there's reduction involved here, for every correct reduction you get a mark. So this should not take you more than 3 or 4 lines maximum. Let's start. Just a reminder, your cast diagram, that's what you need here. This stands for cosine, for all functions, for sine and for tan. It tells us, where our ratios are positive. If we move in the anti-clockwise direction, we're moving in a positive direction. If we move clockwise, we move in a negative. So this negative you see in front of this x here is a movement that is clockwise. Okay, now I'm going to show you how to do this without manipulating anything necessary like that sign over there. So let's start. The first one, we ask ourselves, which quadrant am I in? So which quadrant? I am in the second quadrant. Then you ask what happens to the ratio in that quadrant. Is it positive or is it negative? We see it's the sine ratio, so it's positive in the second quadrant. So it reduces immediately to the sine of 2x. You've got your first mark. There's nothing here, Valentine, that we can do to the cosine, so we just keep it hanging on there for now. Here we have a dangerous situation. We have 90 degrees. Now 90 degrees, whenever you see the 90s or the 270s, folks, remind yourself that you're working with co-ratios. So if I have 90 minus x, let's just see, there goes 90 minus x is in the first quadrant where all ratios are indeed positive. Okay, so cosine is positive in the first, but cosine, because of the 90, becomes its co-ratio, which is the sine of x, and don't forget the 2. So there you have 2 marks so far. Let's continue. 180 minus x, it's 180 minus x is in the second quadrant. Tan, so the quadrant is second, the ratio is tan. In the second it's negative because it's only positive in the third. So this reduces to, now please here, in a bracket, minus the tan of x. In fact, for all 3 of these, folks, so that you do not fall into the trap, put each one in a bracket. You're multiplying them together. Okay, don't do it right from the start and just change this sign. Okay, so here we have the cos of 180 plus x. Well, so there's 180 plus x is in the third. Cos is negative, so it becomes minus the cosine of x in a bracket. Now, can you imagine if you change here? Now you've got to cross out and put a minus. So please take my advice, folks, and use those brackets. Let me show you how to find this one. Now, we know that 720 is 2 360s. So it's 2 revolutions. Okay, so where's minus x? Well, minus means it's negative. So there, let me use another color. There is minus x. Then I go minus 360, minus 720, and I'm at the same place. What happens to sine in the fourth quadrant? Sine is negative. So this is minus the sine of x. Okay, now this looks quite promising. We're on our second step. Now remember what tan is. Let's first, hang on. Let's first get rid of these signs. A minus times a minus is a plus, times a minus is a minus, times another minus becomes a plus. Now remember, what is tan? Tan is the sine of x over the cos of x. Now if the cos of x is in the denominator, and there's a cos that's not in the denominator, those two are going to cancel one another. Okay, so tan became sine over cos. The cos is cancelled, so I'm left here with sine multiplied by sine, which is sine squared x. Okay, now I've got to take care of this. So there's a double angle over here. That double angle I can expand immediately into sine x cos x. Now check here. That is multiplied by another cos. So this becomes cos squared x divided by 2 sine x. And folks, look at the poetry here. The 2 sine x cancels the 2 sine x, and you're back at a grade 10 identity. Cos squared plus sine squared is 1. And there's your 7 marks. Quite easily done. 3 lines. No, 2 lines. No, 3 lines, if you count the last line as a line. Okay, so 3 lines for 7 marks. Don't think because there's 7 marks you must write 15 lines. Not necessary. How do we mark this? We go to the answer, we say, answer is perfect, student gets marks. Okay, let's look at the next one on Valentine's paper. It says prove that. So if the prove that comes in, it's an identity grade 12s. So you keep your left-hand side and your right-hand side separate from one another. And the goal here is to show that those are identical to one another. So let's start with the first one. Again, it's our cast diagram that comes in to play. But this time we have numbers. Now we know there's 180, there's 270. So this sign is definitely, I'm going to start with the left-hand side rather. I should have said that first. Because on the right-hand side, there's one ratio. The only thing I can do with cos 2 theta is choose one of 3 expansions and then it's over. So there's more work on the left-hand side. Okay, so this is 180 plus 54 in the third quadrant where sine is negative. So it's minus the sine of 54 degrees. Folks, you do not have to show every single step here. Anybody can take a calculator and say 234 minus 180. Okay? As long as you know that you're in the correct quadrant and that your reduction is perfect. Let's look at that denominator. That denominator is an acute angle, so I'm not going to touch it for now. I'll decide later on what to do with it. Minus. Now here's a beauty. I love things like this. Let's see how we interpret it. You are not matrix. And if there's any grade 11s watching, look at what I'm going to show you now. You are not going to manipulate that rule. You are going to say the x is positive. So I move an acute angle of x into the positive direction. And then I subtract 90. I go back 90. Which quadrant am I in? I'm in the fourth quadrant. What happens to sine in the fourth? Sine is negative. What happens to sine because of the 90? It becomes the cosine of x. As easy as that. No writing in between. Draw a little rough diagram for yourself and that's how you're going to do these manipulations. This one is straightforward. It's 90 minus 2x. It's in the first quadrant where all ratios are positive. So cosine is positive. But cosine becomes the sine of 2x because of the 90. Divided by, here's the same thing. We go in the positive direction x and then a revolution in the opposite direction. We end at the same place, so sine stays the sine of x. It's a first quadrant angle. Okay, now let's have a look. The right-hand side, we're supposed to get an answer of cos of 2x. So let's see. If I look at 36 and 54, 36 degrees plus 54 degrees, folks, is 90 degrees. Okay, so the angles are complementary angles. Now we ask ourselves, are the ratios complementary? Let's see. Indeed. Sine and cosine are each other's complements. So this whole thing over here reduces to minus 1. The sine of 54 is the same as the cosine of 36. The angles are complements, the ratios are complements, they say goodbye. and what's left is the minus 1. So we're quite happy for that. Now let's continue. Here's a minus times a minus, which I'm going to make a plus over there, that negative and that negative. I have a cosine of x, so let's see what, I can't do anything more with it. But over here I have 2 sine x cos x, and all of this is divided by the sine of x. Now please, Valentine, make sure that you know these rules. These rules are on your formula sheet, but you don't have time in an exam to page back and forth to go and find formulas. So know them, then you can do your work as quick as this. Okay, so we're going to simplify. The sine says goodbye to the sine, and I go into stage 3. 1 plus 2 cosine squared x, cos times 2. And look at that. That is the cosine of 2x. So all that's left for me is to conclude now that this is identical to my right-hand side. And for 7 marks, you've proved that identity. Okay, so folks, get yourself these shortcut methods, know your reduction formulas, know your identities, so you don't waste time in an exam trying to find them. The third one I love. The third question says, you are given the sine of m, which is 40, the sine of 40 rather, which is m. Express the following in terms of m. Now I always just make myself a little diagram over here. This is 40. Now the complement of 40 is 50. The sine of 40 is opposite over hypotenuse, so this is 1 minus m squared, if I ever need that. Okay, so we must take what's written here and write it in terms of m. To be able to write it in terms of m, we either have to write it as a 40 degrees and a sine of 40, or a cosine of 50. Again, your complementary ratios come in. So let's not waste time. Let's go with a cosine here. This cosine, according to my cast diagram, is in the 4th quadrant. It is 50 degrees away from 360. So immediately, cos is positive in the 4th, and that becomes cos 50, which I can tick off is an m. Let's look here at the sine of 150. Now the sine of 150 is in the 2nd quadrant. It's 180 minus 30, so that becomes the sine of 30 degrees. Okay, that looks beautiful, that looks promising. We can get rid of the cosine of 50. We can change this as well to a half. The sine of 30 is a half, so that's a special angle. Let's continue. For the sine of 140 is in the 2nd quadrant. 180 minus 40, sine is positive, so that's the sine of 40. And the tan of 135, again, be careful, brackets. I'm telling you to use brackets and I don't even use them. Okay, so tan of 135 is in the 2nd quadrant. It's 180 minus 45. So this becomes minus the tan of 45, excuse me, because it is in the 2nd quadrant. Okay, so we can get rid of the cosine of 50 is adjacent over hypotenuse, so that is m, and our sine of 30, now remember your special angle triangles, know them off by heart. This is 60, that is 30, that's 1, 2, and that's root 3. The sine of 30, 1 over 2. So this becomes over a half. Plus, over here we have 4m times minus 1. The tan of 45 is indeed a negative 1. So here we end up with 2m minus 4m, and that gives us a result of minus 2m. The important things here, folks, is to locate your quadrant, get the right sign of the ratio in that quadrant, and then do it in the quickest possible way that you can. Okay, let's move to our next question. I love this one as well. It's a beautiful graph that they've given us. There's an amplitude shift, and then there's a phase shift. So there's a horizontal movement, and then there's a vertical stretch. Determine the general solution for 4 marks. So this should not take much more than 3 lines, 4 lines maximum. Let's see. For f of x to be equal to naught, it's minus a half the sine of x plus 30 degrees, which is naught. Now, folks, this minus a half just divides away to the other side. So we didn't even need to put it in there. We are just looking at this being 0. Now, where's that 0? Well, that is 0 if you know your definitions, where x plus 30 is equal to, now remember there's two places where this happens. It happens at the inverse sine of 0, or it happens at 180 degrees minus that inverse sine of 0, and then plus multiples of the period for sine, which is in this case 360. Okay, now we all know the inverse sine of naught is naught because the sine graph starts at naught, naught. So we can immediately say that x plus 30 is going to be equal to naught degrees. 180 minus naught is 180 degrees, plus multiples of the period, which is 360. All that's left for me is to now throw the 30 over. So x will be minus 30, or 180 minus 30 is 150, plus multiples of the period for the sine graph, and that n is indeed an integer. So yeah, that is our first part of this question answered quite nicely. It's a lovely question. It's not trying to trick you in any way for the 4 marks that they're going to give you. Okay, let's see, what do they ask next? They say, write down the minimum value of this function. Now, we've just seen that the function has an amplitude of a half. This, without the half, if this was the only thing we had, its amplitude will be 1. So it'll have a maximum of 1 and a minimum of minus 1. But now with that half, there's a shift in the amplitude. So the minimum value is at y equals negative a half for 1 mark. Okay, so you should know your graphs like that. You know your graphs like you know your name and your surname, the critical points on the graph, so you can just move away based on what they've asked you. Like in the next one, they ask you, determine the range of this function plus 1. So what happened here? This plus 1 is a vertical translation of 1 unit upwards. Now, if I put the range down of the original, the range of f was the elements minus a half to a maximum of a half. Okay, so what is the range of that f of x plus 1, if I can call it like that? Well, the whole graph moves up 1. So what do? I add 1 to each of the limits in that interval. So that range there will be a half and 1.5. So this whole graph just moved up 1 unit, where it was at minus a half here and a half. Plus 1 is 1.5, plus 1 is indeed a half at the bottom, the half minus a half. Okay, now they say, now this is a lovely question. This is a transformation of the original graph. Now remember, the original graph was f of x, which was minus a half sine x plus 30. Let me just make sure. Yeah, there we go. So now it says it's translated 60 degrees to the left. Now remember, if you move to the left in your head, you're subtracting, okay? But actually in that equation, you're going to add. So what happens? It is a phase shift. So here, I need to add 60 degrees, okay? Then I have actioned my first transformation. So let's do it in the color blue. The first transformation changes f of x into, it's not yet h, so f of x plus 60 in this case then will be minus a half sine x plus 30 plus 60 is 90. Oh, and that is a beautiful reduction formula. Which quadrant is it in? Let's see. X, first quadrant, plus 90 puts it in the second quadrant, where sign is positive. So this stays minus a half for now. Sine, because of the 90, becomes the cosine of x. And hence they said here, in simplified form. That's where your simplified form came in. Now we're ready to h of x this. What do we do now? Well, they say for the second transformation, you reflect it in the x-axis. Now, folks, we know that if we reflect in the x-axis, let me write this down. In the x-axis, the y's become minus y's. So basically, the sign changes in this case. Okay, so what happens? H of x is then going to be a half cos x. And there, only thing happens there, this applies to that negative. It disappears. The negative becomes a positive. And our final graph is a half cosine x. Let me see. Yeah, we've answered your whole question, Valentine. Thank you for that question. It's quite a lovely question. It covered quite a lot of things that you need to know in trigonometry.